Okay, we will start. In the morning class, we were discussing about the type of transmission mode. You had two categories of transmission mode. One is parallel transmission and another one is the serial transmission. And also in serial transmission, you have got other three modes of timing signals. One is asynchronous mode, synchronous mode, and isochronous mode. Now you're going in detail with one more type of transmission mode that is called it as the simplex mode of transmission, the half duplex mode of transmission, and full duplex mode of transmission. So morning I told what is a simplex mode of transmission. Simplex mode of transmission means here if you have two devices, only one of the device can transmit at a time. The other can only receive. That means the direction of data is unidirectional. It is like a one-way traffic. The vehicles are allowed to move only in one direction. The same is case for the simplex mode of transmission. As an example, if I'm telling the communication between the keyboard and the CPU or CPU to monitor and keyboard, traditional monitors, all these are examples of simplex devices. So what about the capacity of the channel? The capacity of the channel is entirely used by the device who is transmitting the data. See, out of the two devices, one can only transmit and one can only receive it. So whoever is transmitting, they use the entire capacity of the link. Okay. So that is the simplex mode of transmission. Now next is the half duplex mode of transmission. Here you have two stations, and what it means is both the stations can transmit as well as receive, but not at the same time. Both can transmit as well as receive, but not at the same time, right? It is like, as an example, if I'm telling it is a one lane road. What about the one lane road? In a one lane road, only the vehicles can, but the traffic is allowed in both the direction. But if it is a single lane road, only the vehicles that is going in only in one direction can move at a time, right? The other side vehicles has to wait. The same case is the half duplex transmission. So the capacity of the channel is entirely utilized by the device whoever is transmitting at that time. At a particular time, who is transmitting the data, they are making use of the entire channel. And that is the half duplex transmission. Now, the third one is the full duplex. An example for a half duplex is it is walkie-talkie. Now, the third one is the full duplex mode of transmission. Full duplex mode of transmission means here both the devices can transmit and receive at the same time. Okay, both the devices can transmit and receive at the same time. That means simultaneously they can do. It is an example. A two-way street is an example for a full duplex communication. Two-way street means the traffic are allowed in both the direction at all the time. Now, what about the capacity of the channel in this case? The capacity of the channel is shared by both of the devices. Okay, so these are the other type of classifications of the transmission mode. One is the simplex mode, the half duplex mode, and the full duplex mode. I'll repeat once again. Simplex mode is unidirectional. Only one of the devices can transmit. The other device can only receive. The capacity of the channel is utilized by the device who is transmitting the data. Okay. Now, second one is the half duplex mode of transmission. Half duplex mode of transmission means here both the stations can transmit as well as receive, but not at the same time. At a particular time, only one station will be transmitting. The others has to wait for the transmitting the next data. Okay, so it is like a one lane road. Now, the capacity of the channel is fully utilized by the channel whoever is transmitting at that time. Now, the third is called the full duplex transmission. Full duplex in the sense both can transmit as well as receive simultaneously. Example for a full duplex communication is your telephone network. Telephone network, what both can talk as well as listen at the same time. Okay, I hope you understood the three differentiation between simplex mode of transmission, half duplex mode of transmission, and full duplex mode of transmission. Is it clear? Can anybody answer it? Is it clear or not? Yes. Okay, good. Now, we will move on to the networks part. So far we were discussing about the data communication, its effectiveness, its components, then the different types of modes available. Now you're going in detail with networks. As you all know, network is you are having a set of devices. Those set of devices can be called as nodes, and they are connected by media links. Okay. Now that interconnection, I told all the nodes are autonomous in nature, but they are interconnected together either by wired medium or a wireless medium. Now that interconnection is only meant for communication part, right? So you can call that link or the links connecting these devices, you can call it as the channels. Now the main important usage of a network is distributed processing. Now what does mean by distributed processing? You are having a task and you are just splitting it about among the multiple computers. Okay, so this is just a definition of network. Network is a connection of interconnected nodes which are connected together in order to share data as well as resources. Okay, now coming to the criteria of networks. As how we explained the effectiveness of data communication system, similarly, you can also tell that a network is an effective network if it satisfies three criteria. One is the performance, the other one is the reliability, and the third one is security. I'm repeating, a network is considered effective or efficient if it satisfies some criteria. Out of, you have many criterias. The major one are the performance, reliability, and security. Now, what about the performance? Actually, performance can be measured in many ways. That includes the transit time as well as the response time. Now, what do you mean by transit time? Transit time is nothing but it is the amount of time that is required for a message to reach the destination from sender to receiver. It is the amount of time required for a message to reach from sender to receiver. That is called it as the transit time. Now, what do you mean by response time? Response time is the elapsed time between an inquiry and a response. The meaning is, I am requesting for a service. Now, how much time it take to respond for that service? That is called it as the response time. I hope the two things are clear for you. One is the transit time and another one is the response time. Transit time is the total amount of time that is taken for a message to reach from sender to receiver. But response time is if I am requesting for a service, how much time will it take to respond to that service? That is called it as the response time. Usually, performance is depending upon this transit time as well as the response time. Okay, now, other than that, it also depends upon four factors. One is the number of users, the type of transmission medium, the hardware, and the software. Now, explaining each concept, number of users. Number of users in the sense you can have a lot of users at using the network. So having a lot of users in a network, that will slow down the response time. You're getting response time, I told, the time that is taken, it is the elapsed time between an inquiry and a response. That you are offering a service and how fastly you are getting that service. That is that response time. So number of users, if more number of users are there, then the response time will be very slow. Okay. Now, As far as network designers are considered, they will be making an assessment on the average number of users that can be used in a network at a particular time. So at a particular time, a network designer, what he will do is he will make an assessment. Okay, this much is the average. These are the number of average users that can use the networks at a particular time. Now, what happens at the peak load hours? At the peak load hours, if the total number of users, if it is exceeding the average value, then what happens to the performance? Performance also decreases, right? So I hope you are getting. Performance means it depends upon the number of users. Lot of users are there means you are slowing down. The response time will be very much slow. It will be affecting the performance of a network. So each time you have got an average number of users, you have a limitations on the number of users, and once it exceeds that limit, then the performance will be, it will affect the performance, right? Now the second one is the type of transmission medium. I have already told you have got different types of medium, coaxial, twisted pair, then optical fiber cable, etc. Now, nowadays, most of the networks, they are using this optical fiber cable. Now, what is the advantage? So actually what is the speed in sending the data through a connection? Suppose if the medium sends a data at 100 megabits per second, and is it 10 times powerful than a network who is sending data with 10 Mbps? Yes, right. So with more capacity, how fast you can transfer the data, how many bits you can transfer in a second. So it depends upon the medium, right? So performance also depends on the type of the transmission medium that is being used. Now the third parameter is the hardware use, the type of hardware. How efficient the hardware components are, which are used in the network. If you have a high storage capacity computer, then the performance is better in that case, right? Now, the fourth parameter is the software. Software is how you're going to process the data as far as the sender is concerned, receiver is concerned, how far about the intermediate nodes. So the efficiency of the software is also a parameter that depends on the performance of a network, that affects the performance of a network. Hope that four things are clear for you. So I told performance is the first criteria that I can tell a network is, it depends upon how the network is an effective or an efficient network. So performance, it is mainly based on the transit time as well as the response time. And it is also depends upon the number of users, the type of the transmission medium, the hardware, and the software. Is it clear for you? Number of users. Can anybody answer the four terms? Is it clear for you? Yes. Okay. So the total number of users, type of the transmission medium you are using, the hardware, type of the hardware, and also the efficiency of software, right? Now, the second criteria is the reliability. Network reliability is measured by three things. One is frequency of failure. Second one is the recovery time of a network after a failure. And the third one is network's robustness in a catastrophe. What is frequency of failure? You cannot always tell that all the networks will perform in an efficient manner all the time. That won't happen at all. The network may fail often, or sometimes the network will be failing continuously. Is that useful for the user? Such a network is useful for the user? No, right? So network reliability, it depends. It is the one of the factor is the frequency of failure, right? Now the second one is if a network fails, now how fast it can recover from that failure. If it is not at all recovering, then it is of no use to the user also. right? So that recovery time also, it's very, very important. Now, the third thing is its robustness in a catastrophe. Catastrophe means a sudden damage, like an earthquake, like a fire. So whatever is happening suddenly, that is called it as catastrophe. Now, how much a network is robust against all these attacks? So that also it depends. I mean, the reliability is a parameter for that. Okay, so the second criteria how you can find a network is efficient or effective is the reliability. And reliability, it depends upon the frequency of failure. It is measured, not depends upon, actually it is measured by the frequency of failure, the recovery time of a network after a failure, and its robustness in a catastrophe. Okay, now the third parameter is the network security. The third criteria is network security. Network security, as you all know, whatever data you are sending and receiving, that should be protected, right? It should be unauthorized access should not be there, and it should be free from viruses also. Okay, so that is about network security. So these are the major parameters that determine the criteria for a network to be an effective one and as well as an efficient one. So I repeat, the three parameters are performance, reliability, and security. Performance, as already I told, it is measured by mainly the transit time as well as the response time. And also it is depending on the number of users, the type of transmission medium, the hardware, and the software. Now, reliability is measured how fast a network is recovering from a failure, how often a network fails. All these parameters, it depends. And also how robust a network is. Robust is when a sudden damage happens. Now, the third one is the security. Security means you have to protect your data from unauthorized access and viruses. Is it clear? Now you have got many applications like in business applications, home applications that you can just read it. Now what are the business applications? Now what are the home applications of network, right? I hope this much is clear. So morning, I have told about the transmission modes. Then we have come across the network, and in that network, we have just learned about the criterias of the three criteria that determines a network to be efficient and an effective one. Hope is it clear for you? Yes or no? Yes. Okay. Now, now we will move on to the basic concepts of network. In that, first we will be studying about the physical structures of network. Physical structures in the sense how the devices are connecting on a link. You should imagine you are having nodes there, and how you are going to connect those nodes in a link. That is also called it as line configuration. So line configuration, it defines the attachment of communication devices to a link, right? So how your communicating devices or the nodes are connected to a link. Now you can have two possible configuration. One is called the point to point connection, and the other one is called multi-point connection. Point to point, in that word itself the meaning is understood, right? Point to point, now you can see in the diagram, point to point means you have a dedicated link between two stations, right? The dedicated in the sense the link is only meant for that two stations. Understanding? Point to point means you are having a dedicated link or channel between the two stations, and the link is only utilized by those two devices. Okay. Now the capacity is entirely utilized by those two stations. Okay. So such type of connection is a point to point connection. Now the other one is called it as the multi-point connection. Multi-point in the sense you can have any number of nodes, and these number of nodes, if they are connecting to a single link or they are sharing that link, that is called it as multi-point connection. You can have many nodes or stations that are attached to a common link. Now, what about the capacity of the channel or the link here? The capacity of the channel is shared. Now, that sharing can be done by two ways. One is temporal sharing, and the other one is the spatial sharing. Spatial in the sense that the one which is related with space. That means each is having, all the links all the devices make use of the link in a simultaneous manner. But what about temporary sharing? Temporary sharing means if a station take turns for transmitting the data, that is called it as temporarily sharing. So these are the type of sharing that takes place in a multi-point connection. Multi-point means many nodes will be there. Those nodes are connected to a common link. The capacity of the channel is shared among those stations. And that sharing takes place in two ways. One is by taking turns, they can transmit, or they can transmit simultaneously. Right? So this is about the line configuration. Line configuration means how the devices are connected to a link. Okay. Now you're going to the another category of this network that is called it as topology. So I told about line configuration. You can have two type of line configuration, point to point and multi-point. Okay. Now, two devices can be connected on a link. That is called it as line configuration. Now, what about two or more links? How the links are connected? That defines the topology. It is the logical representation of links in a network. How you can, what are the various ways a link can be connected? What are the physical or what are the representations available in a network? That is the term topology means. Now, mainly you can have four different types of topology. One is called it as the mesh topology. The other one is the star topology, then the bus topology, and the ring topology. So topology, you can classify it into four. One is called it as the mesh topology, star topology, bus topology, and the ring topology. Now, what about the mesh topology? When you are considering a mesh, there is a diagram that shows a mesh topology with 5 devices. Now, what you can see in this, you can have 5 devices, and each station, between 2 stations, you are having a dedicated point-to-point link, right? Between 2, so if I'm considering one station to the other station, I am having a dedicated point-to-point link between those 2 stations, right? So if you have got n stations, how many links are required actually? You require n into n minus 1 links there. That means if you have 5 nodes, almost about 20 links you require in order to connect each and every device to each other. But if a link is able, if they can support full duplex transmission, that is the transmission both the stations can transmit and receive at the same time, then the total number of physical links that is required is n into n minus 1 by 2. So if you have 5 stations, you can have 10 links in that. Okay, so the diagram shows that one. So what a mesh topology means is between stations, you are having a dedicated point-to-point connection, a point-to-point connection between 2 stations. Okay, now the traffic is only meant for those 2 stations. Now, what are the if you want to connect these many links, then n minus 1 input output ports are required. N minus 1 input output ports are required in order to connect all these things. Now, what are the advantages of this mesh topology? eliminates the traffic problems. What do you mean by that? Eliminates the traffic problems. See, since only two devices, since they are having a dedicated link, you don't have having much traffic in that, right? So traffic problem is eliminated in a mesh topology. And it is robust. It is very strong. In the sense, if you have 5 devices, out of those, if one of the link, if something happens, then also the others can involve in that transmission. It won't affect the other systems in the network. Now, third advantage is privacy or security. Privacy or security means since a dedicated link is between 2 stations, then only the intended recipient only will be getting that information. So in that you can tell that privacy or security is being provided. These are the advantages of mesh topology. First one is it eliminates the traffic problems since you are having a dedicated point-to-point link between the 2 stations. And also it is robust. Okay. Now privacy or security is also provided in mesh topology. Okay. Now what about the disadvantage of mesh topology? It is that it is depending on the cabling, amount of cabling, the wires that is required or the links that is required. See, I told 5 devices are there. How many links are required? If it is supports full duplex transmission, 10 links are needed. So disadvantage of such a mesh topology is the amount of cabling required and the number of IO ports required, right? So this is one of the category of one of the topologies how you can the network can be laid out. You have many nodes, and these nodes, if they are connected like a mesh, that forms the mesh topology. Mesh topology, you have to just understand you should have a dedicated point-to-point link between the stations which you connected. So more number of cabling is required and more number of IO ports are required. But it is very, very strong. And also it is if one link, if something happens, then there won't be much problem in the entire network. Okay. Now the second type of topology is called the star topology. You can see in the diagram, I have made use of 4 stations. Does the station to station connection is available there? Do you have a dedicated point-to-point link between the stations? No, right? But what about the connection? The connection is going to a central hub. You can call it as an exchange. So whatever connection, how many stations are there, these stations will have a point-to-point connection to the central hub. Okay, so suppose if one station wants to communicate to other station, what they will do is they will send data to the hub, and from the hub it will relays to the destination part. Okay, so star topology, what you have to understand is between station you don't have any connection, but the stations will have a dedicated link towards the central controller or the central exchange or the central hub. So controller, it acts as an exchange. If once wants to transmit a message, it will send directly to that hub, and then from there it will be relaying it. Okay. Now what are the advantages and disadvantages of this star topology? Star topology, when you are comparing the mesh topology, the star topology is not much expensive. It is less expensive than a mesh topology. And also it is robust in the sense you can have, if one link fails, what happens if one link fails? Only that link is affected, right? And the all others can remain in an active mode. So it is robust. And also you can ease in star, each device needs only one link and one IO port to connect it to any number of others. But what about the mesh? You require so many number of IO ports as well as so many links were required. But when you are comparing the star topology, each device needs only a single link and a single IO port to connect it to any number of others. And also, you can easily identify the fault as well as isolation can be done. So easy fault identification and fault isolation. That's what I told. If one link is failing, then you can identify it and you can just remove it. So these are the advantages of star topology. I repeat, it is star topology is you don't have a dedicated connection between the stations, but you have a dedicated link to the central exchange or hub. Okay, so if one link fails, it won't affect the others, but the other all remains active at that time, right? And also it is robust, right? And you can easily identify the fault, and fault isolation is also easy. Now, what about the disadvantage of this star topology? Now, what happens if that central hub only fails to operate? What happens? Can we communicate? No. So if the central hub fails, the whole network fails to operate. If the hub goes down, the whole system is dead. And that is the disadvantage in case of star topology. And comparing the cables, the more cabling is required than other topologies. When you are comparing with mesh, the amount of cabling required is less. But when you are comparing with other type of topology, we are yet to discuss that, that is ring or the best topology. Here, the number of cables that is required is more. Okay. So these are the two types of topology. I repeat, topology is the way how the network is laid out, how the links are being connected in a network. Generally, two type of topology I discussed. One is the mesh topology and the other one is the star topology, right? Now, the third type of topology is called it as the bus topology. Bus topology, what you can see in the diagram. You are having a single cable. A long cable is acting as the backbone and many stations are connected to it. Now, what type of connection is this one? Can anybody tell? What type of connection is it in a bus topology? Karthik. Is it a point-to-point connection or is it a multi-point connection? Is Karthik there? Yeah, tell me. What type of connection is that one? A point-to-point or a multi-point connection? I can't hear you. Hello? Karthik?
Hello.
Yeah. What type of connection? Multi-point. Multi-point, I have told many stations can be connected to a common link. So the bus topology, it uses multi-point connection. Now, how these stations are being connected is you are by two things. One is called the drop line and another one is by the tap. Now, drop line is nothing but it is the wire that running between the station and the cable, right? Drop line is the wire that is the connection that is running in between the station and the cable. Now, the tap is nothing but it is just a connector that splices into the main cable. You should have connections to the cable, right? To the core, right? So the tap is nothing but a connector that is used to connect to the main cable. So bus topology is a multi-point connection and each station are connected to a long cable with the help of drop line and with the help of a tap. Okay, now what are the advantages of this bus topology? Bus topology is you can easily install it and also it uses less cables than the mesh or the star. When you are comparing mesh or the star, it is easy. I mean, the number of cables that is required is less. Now, the disadvantage, difficult reconfiguration and fault isolation. You can install the devices easily, but once if there any problem in that, then it is you are not able to reconfigure it and you are not able to identify the fault. right? And if you are having a break in that cable, what happens? It will stops all the transmission. Okay, so fault or break in the bus cable stops all transmission. Okay, so three topologies I discussed. What are they? Mesh, star, and bus topology, right? Now, the last one is called it as the ring topology. Now, what you can see in the diagram again, it is in the form of a ring, right? Now, what it means is each station will have a dedicated point-to-point connection to the devices adjacent to it. That is, each device will have a point-to-point connection. What is the meaning? Point to point. A dedicated link is between stations, right? Between two stations. So, whoever are the neighbors of a particular station, you have a dedicated link between them. Okay. Now, if one want to communicate with the other, the signal will be passed along the ring, and whoever is the once it reaches the destination, they will accept that information, right? So now here in this case, like here you are making use of a repeater there. Repeater is nothing but it is used to regenerate the bits and passes it. So once it reaches the station, it will identify whether that message is intended for them. If it is not, what will happen? It will regenerate the bits and it will pass on to the next device. Okay, that is in the form of ring topology. Now, what are the advantages and disadvantages? Ease of installation. You can easy in installation part, and you can also configure it in an easy manner. Now, our add or delete a device requires changing only two connection, right? Since we are having a point-to-point connection, if you want to delete or if you want to add a device, it requires to change only two connections. Now, fault isolation is simplified in this case. Now, if one device does not receive a signal, what happens? Out of that many devices which are connected in a ring, if one device, if it does not receive a signal within a specified period, now what happens? An alarm clock, an alarm is there, or it can issue an alarm and alerts the network operator to the problem and its location. Okay, actually that is happening with the help of a token. The token will be passed from station to station, and if a station is not receiving the token, then they will wait for a specified amount of time, and what happens here it is, and again, if nothing is happening, they can identify that some fault has been occurred. Okay, so if there is a break in the ring, then that will fully disable the entire network. And in the ring topology, you can have unidirectional traffic. You cannot go in both the directions. The token can pass only in a single direction. Okay. Hope it is clear, these four type of topologies. The remaining thing that I'll take it in the next class. So I am just concluding today's portions. So what are the things that I have told? I have told the two types of line configuration. One is point to point and another one is multi-point. Point to point means a dedicated link between two stations. The channel is exclusively meant for the two stations. Now, multi-point means many devices can transmit. Many devices are connected on that link. And here sharing takes place. The link is utilized by sharing process. Two ways you can share it. One is spatial sharing. The other one is temporally sharing. Based on the turns, you can share the link. Now, next, I have told about the topology. Topology is nothing but it is a representation of the link on a network. How the network is laid out. Generally, you can have four different types of topologies. One is the mesh, star, bus, and ring. So when I tell each word, the thing should come into your mind. Mesh means fully connected devices. Each node, many stations will be there, and you can have n number of connections to all other stations. So that imagination should come in your mind once I tell each word, right? Now, star topology. Star topology means you can have a central hub and the connections will be going to the central hub. Bus, a long cable is there. Devices will be connected to a long cable. Ring, all the things will be connected in the form of a ring, and a unidirectional traffic is only allowed in the case of ring topology. Hope you understood this one. Okay, now all of you attempt that quiz question today itself, because the due date I have kept it today. So if anybody is not getting that, please inform me after 1:30 or once you finish your classes and refresh your thing. I mean, by I'll be here in the college up to 3 o'clock. So if you want to communicate within that time or beyond that also, you can, there is no issue in that. You can communicate with me. So, but today itself, I need all of you to attempt that quiz. Okay. Now, all are present now. I have marked few absenters. Afla C is there. What are the things I have to today? What all topics I have covered today? Afla. Yeah. What are the things that I have covered today? What are the main two topics? Hello? You are not there in the class then. Okay, Ajmina, you are there? Yes. And now you tell what are the topics I covered.
Types of connections.
Okay.
Point to point and multi-point.
Okay. Then
topology.
Topology. Now Karthik is there. Karthik?
Yes.
Yes. Now what are the different types of topologies?
Multi-point.
Point. What are the types?
Topology.
Yeah.
Topology.
ഇത്ര പെട്ടെന്ന് മറന്നു പോയോ?